In this video segment, we will return to the retirement planning of Tectra Nologian of the previous chapter to illustrate non-annual concepts and techniques. Included will be the situation of converting rates and payments to different compounding frequencies and also gradient increases in payments. Tectra has decided to invest in an annuity annually. She gets a bonus every year, and she's going to put $6,000 in the first year payment, and then every end of the year take a certain amount of her bonus and put it in this here retirement plan. And each year she expects that to increase 3% annually. So if it's $6,000 in the first year, 3% greater is $180, so she'd put in $6,180 in the second year, $6,365.40 in the third year. The fund that this goes into pays 5% interest, that's the NAR, nominal rate, with monthly compounding. So to figure out the interest on an annual basis, we need an annual rate. So we have to determine the EAR. Note the EAR for annual is the same thing as an annual NAR or an annual PIR when you're dealing on an annual. So we want to convert this to an EAR and use for annual interest. So you can use the effect statement as shown here, D3 the 3%, and the 5%. Increase that up to 5.2. If you prefer equations, 1 plus the 3% divided by 12, raise that whole thing to the 12th power and subtract 1. Either way works identically. So with that, then we can come up with our balance. The interest in the first year is 5.12% of $6,000, or $306.97. We add that to the deposit in the second year and the balance into the first year, and you get $12,486.97. You should note there's no interest in the first year because there was nothing in the account in year 0. It didn't start till the end of year 1, so you don't get any interest in 1 because it started at the end. So we end up with $578,534.64, which is a reasonable plan. Tectra has learned that more frequent deposits draw interest sooner and result in higher balances, so she decided to switch from annual deposits to the more common practice of monthly deposits. The nominal rate of 5% compounded monthly is still used. The payments in each month will stay constant during the year and increase at the end of the year. So each year they increase, but during the year the same. We have an example here where the first year she was doing $6,000 before, 12 into that is $500 monthly. So she starts with that the first year and she'll end up with the same $6,000 as before. And every month it's $500 in the first year, 12 months. The second year, months 13 through 24, she puts in 3% more, that's $15, so it's $515. And that will be, give a balance of $12,777.14. We could continue this on for 360 months, but that's rather laborious. So just note here the interest is done the same as before. There's nothing in year 0, so there's no interest in the first month. Then it's $2.08, add that on with the 500 and so forth, and you get up to this balance. Remember that number, 12,777.14. So instead of using 360 months of data, we're going to reduce that to 30 years of data as shown here. We do that by combining the 12 months payments into one equivalent payment. We do that with the future value function. So we take the 12 payments of $500, they're in D4 here. We're going to do 12 of them, and the rate has to be the monthly PIR. So we have to get the monthly PIR to do this. We started off with 5% NAR, Divide that by 12 is 0.42%. So that is what we use. That's in D7. So D7 is the rate, 12 months, payment $500. The future value of those 12 payments is $6,139.43. So that will be our first annual payment. Then we increase that by 3%. 1 plus D6, D6 is a 3%, or if that's 5, that's not a 6, that's a 5. And that goes up to $6,323.61. The interest on this here period at the annual rate of 5.12, the EAR gives this much interest, 134.10. Add that to deposit, and we get 12,777.14. So note the 6,139 and 1277 we just previously did for year 1. There's a 6,139.43. Here's the 12,777.14. So it does work each year. Just by increasing this by 3%, you get this, or you could also do the future value. So back to this, we have then each year we increase it by 3%. Do our interest calculations and balance. At the end of 30 years, we have $591,978.61. If we want to compare this back to our original, we had 578, 534. Here it's 591, so it increased it a little bit.